the tutorial of the COTSon simulator. And Paul Farwowski, I'm just going to, from ESP Labs, I'm just going to give you a very brief introduction, and then I'll let other people continue. First of all, we're not trying to reinvent the wheel. Okay? So the idea is that this is not yet another simulator. So we're trying to build, and we are building, a framework that's based on three sort of key concepts. One is we want to address the world of next generation architecture, so multi-core, multi-nodes, full system simulation, full software stack, and we want to build that on solid foundation, so something that we know can run the full stack of foreseeable future of application of interest. So commodity license, complex multi-tier applications, new platforms. So that's why we built this on top of AMD SimNow, which is, we will see, is a very solid system simulation platform. We also want to be able to leverage the work that the community has done in various other areas. So we have built an architecture that is pluggable to the extent that you can inject timing simulators of components, something like this simulators I will show, or parts of CPU simulator, or memory system simulators, to take advantage of that. So we don't want to rebuild all of that. And finally, we've built this based on the assumption that we have to abandon the idea of a cycle detail simulator that runs always on in cycle detail level, because that's unaffordable for the kind of phenomenon, granularity that we want to observe for application of interest today. And we want to abandon that in favor of statistical sampling method that turns on and off the individual detail simulation when needed to get the accuracy and the speed that's appropriate for the kind of experiments you're running. So really, what we're trying to address is sort of a grand challenge of being able to faithfully simulate and fully simulate the full software stack of large system composed of up to thousands of computing nodes, each of which is going to have internally, potentially up to hundreds of processing cores and the rest of the system. So we think this is important for two sets of reasons. A set of research reasons, because obviously we all know that simulators are important because you can't keep building prototypes. But we also know that the traditional simulation that most people in the architectural community are used to do not address the new needs of multi-processor and multi-threaded simulations, of being able to run the full application stack in commodity operating systems, of being able to trade off accuracy and speed when needed, and support both micro benchmark that zoom into individual features and macro benchmarking, again, to observe certain behaviors that only occur over time. This is also important because we are ultimately a company from a business point of view, because increasingly we're getting pressure from our customers to help them size the computing clusters to run workloads of the future. This whole new Web 2.0 set of applications is changing the way in which customers think about the problem. They no longer have something that they can reason very well, like an Oracle application or a SAP application that's very well characterized. Now they're running things that change much more frequently, and so they want the system integrators like HP to help them pick the best performance per dollar per watt. And this means that if we can have a better performance prediction system, this translates to actually something that is directly relevant to customers. So how we do this? So COTSon is really what we think is sort of a new breed of simulator that tries to bridge traditional architectural simulator, like SimpliScaler, that sort of live in the space of extremely high accuracy, cycle detail level, but extremely slow speed. We're talking about tens or hundreds of thousands of instructions per second if you're lucky. And the world of fast emulators like SimNow and virtual machines that runs at hundreds of millions of instructions per second, close to native speed, but obviously have zero accuracy because they have a very approximate notion of time or power. So what they're trying to do is bridge the two by building something that has the speed of a fast emulator, because that's sort of the engine running underneath, and the accuracy of an architectural simulator that with statistical sampling we turn on and off. And so you will see today that this is sort of what we're shooting for and what we've achieved. I think I can skip this, and I'm just going to move into the outline. So this is the introduction. In the first part is going to cover the A&D SimNow simulator. So Teresa will go through the details of what it means to build a machine for the functional simulation part of our framework. Then Danielle is going to cover the architecture in more details of the individual pieces of the statistical sampler and timing models, etc., etc. And we're going to have a break. And then the second part is actually hands-on experience part, where Yossi is going to walk through some examples of how to use our SDK and our development environment to actually build simple things like a memory tracer or a timer running on the full system simulation, on full guest, and things that are closer to the goals of some research architecture. And we're going to conclude the tutorial with some discussion about how to obtain the tools if you're interested, because we're open to collaborations and things like that. And with this, if you don't have questions, we're going to let Teresa move to the COTSon part.